Okay, so next topic, we will change the topic a little bit. We'll go back to a specific counting problem again, and this topic is on what we call multinomial coefficients. Okay, suppose that you have a set of n objects and you want to divide them into k distinct groups of respective sizes n1, n2, and k. So that means n1 plus n2 plus n3 plus plus nk is 1. Is that making sense? So you have let's say I have 30 students in this class, and I want to divide them into, let's say, 6 subgroups where each subgroup has size 5. So I want to divide the class into groups of 5, let's say. Am I making sense? How many ways can I do that? So here we are saying we have n distinct objects. We want to divide them into k groups, k distinct groups, where the sizes of the groups will be n1, n2, nk. So therefore the sum of n1, n2, and k will be the same as the total n. I have a total of n objects. So the question is, what's the number of such divisions? So how many ways can I divide n objects into k groups of size n1, n2, nk? Right, that's the question. Is the question clear to you guys? To make things simple, let's say I have 3 people. Let's say 5. I have 5 people, and I want to divide them into 2 groups of size 2 and 3. 5 people, let's divide them into 2 groups of size 2 and 3. How many ways can I do that? That's the question. How many ways could I do that? Could I do that? Is that making sense? Is everybody clear on what the question is asking? And then let's move on to the answer. Okay, so how many ways, what's the total number of possible choices for group 1? Well, in group 1 I have n1 objects, right? I have a total of n objects. In group 1 I need n1 objects. So how many ways can I pick group 1? It'll be n choose n1, right? N choose n1, right? Okay, once you have picked group 1 though, right? Remember, you want the groups to be distinct. So once you have picked group 1, how many objects are left? Once you have picked group 1, how many objects are left? N minus n1, right? Okay, from the n minus n1 objects, you want to choose group 2 of size n2, right? So how many ways can you do that? The number of possible choices for group 2 would be n minus n1 choose n2, right? Okay, so once you have chosen group 1 and group 2, how many objects are left? How many objects are left once you have picked group 1 and 2? It will be total number n minus the groups, the size of group 1 minus the size of group 2, right? Is everybody clear? So the number of possible choices for group 3 then would be n minus n1 minus n2 choose n3, right? So You guys tell me what's the number of, well, let me hide it. So what is the number of possible choices for the last group K? For the kth group, how many choices will we have? Yeah? Anybody? What choices do we have for the last group then? After you have chosen the first K minus 1 groups, how many objects are left? Yeah.
N minus 1 minus
2
n sub 2
dot dot dot.
n sub k minus 1.
Yeah. Yeah. So the number of possible choices for the kth group then would be n minus n1 minus n2 minus dot 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 minus nk minus 1. Choose nk, right? By the way, can someone tell me what is this number? The number of possible choices for the kth group, right? Can you tell me what's the value of this binomial coefficient? N. What is n1 minus, what is n minus n1 minus n2 minus dot 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 minus nk minus 1? What's the value of that? nk, right? That's nk, because remember, n1 plus n2 plus n3 plus dot dot plus nk is equal to n. That's the total number n. So this is exactly nk. So you actually have just one choice, right? Once you have picked the other ones, right? Which makes sense, right? If once you have made all the other groups, and for the last group, right? Whoever are left will be in the last group, right? So there is only one way of picking the last group, the way we are picking. Okay, so the counting principle says that the number of possible divisions of n objects into k distinct groups of respective sizes, n1, n2, dot dot dot, nk, is given by, now you multiply them, n choose n1 times n minus n1 choose n2, n minus n1 minus n2 choose n3, dot dot dot, n minus n1 minus n2 minus dot 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 minus nk minus 1 choose nk. Is that right? That's by the counting principle. So we looked at how many ways we can pick group 1, how many ways we can pick group 2, how many ways we can pick group 3, how many ways we can pick group 4, and so on. And then we multiply them to get the total number of ways we can divide n objects into k distinct groups of sizes n1, n2, dot dot dot, and k. Is everybody clear on that? Let me know if you're done writing it down. Okay, so if you're done writing it down, let's see what that is. What is n choose n1? N choose n1 is the same as n factorial divided by n1 factorial times n minus n1 factorial, right? What is n minus n1 choose n2? N minus n1 choose n2 is n minus n1 factorial divided by n2 factorial multiplied by n minus n1 minus n2 factorial, right? You guys know the formula for the binomial coefficients in terms of the factorials. So the next one would be n minus n1 minus n2 factorial over n3 factorial, n minus n1 minus n2 minus n3 factorial, dot dot dot, the last one. Okay? So what you need to notice here, the pattern of cancellation. So you have n minus n1 factorial cancels out, n minus n1 minus n2 factorial cancels out. So the cancellations are like this. So once you do the cancellations, all you will be left with is n factorial divided by n1 factorial, n2 factorial, n3 factorial, and so on. Okay? So we get n factorial over n1 factorial, n2 factorial, and k factorial. In fact, this argument that I just gave you, somebody in the class used it in the exam when you answered number 14, I think. 14, yes, 14. Somebody in the class used this argument. I think the question was how many ways you can assign teachers into schools, right? I don't know exactly who that was, but somebody used that argument. The same argument that we are using here. Okay, so notation that we're going to use, this fraction n factorial over n1 factorial plus n2 factorial plus times times nk factorial, where n1 plus n2 plus nk is n. This will be called the multinomial coefficients, and we are going to denote that fraction by n choose n1, n2, nk. So this is like a symbol like the binomial coefficient. This is called the multinomial coefficient. So what is the multinomial coefficient telling you? It is telling you the number of possible divisions of n distinct objects into k distinct groups of respective sizes n1, n2, nk. Why don't you write that down, and then we're going to end. Now, anybody in the class remembers seeing that expression before? Have you seen that fraction n factorial over n1 factorial times n2 factorial times and k factorial before? Who has seen this before? Well, every one of you have seen it before, but who can remember that? Where have you seen this before? Remember, we looked at the number of permutations of n objects where n1 of them are alike, and 2 of them are alike, and k of them are alike, right? The number of permutations of n objects where n1 of them are alike, and 2 are alike, and k are alike, you got the same value. Is that making sense? Why do you get the same value? Well, why don't you take that as a mental challenge and solve that? Okay? All right.
I was wondering how you got number 1 because I plugged that into my calculator and I got B.
I think what's happening is that the definition of how you compute the quartiles or percentiles, it depends on what definition. So some books may have a little bit different definition.
Okay.
So the definition that we picked for the quartile, right? So what is the 25th quartile? So you multiply it with, what's the total number? 13?
None of this makes sense.
And what do you get? I think you get 3 point something. So the formula that we are using for quartiles is that once you have 3 point something, then you take the ceiling of that. So let's say 3 point, I don't know exactly what, let's say this. And you get 4. So the fourth one should be the first quartile. Okay, but in some texts I have seen is that, so once you pick the middle one, now 299 is the middle, right? To pick the first quartile, they take the median of the lower half. So if you take the median of the lower half here, you're gonna get the average of these two, and I think that's what you have here.
Okay.
Okay, so the definition we took was different.
Okay.
But how many points did I?
I think 2.
2? Okay. I think everybody left, but everybody who got 2 points off, just talk to me next time, Monday.
Okay.
I'll give you the points back.
Okay.
Because I didn't realize that until too late, so I forgot to change that. Some books have that different calculation,
I
but
think that's
ours
the way.
was that.
If you type all the numbers into a
Yeah.
calculator, that's how you're
Yeah,
calculating.
And
so-
I think when we did our homework,
And that's a problem because
the homework, the right answer was like if you did it like that.
in the homework actually it takes both A and B. I checked it.
Oh, okay.
It takes both A and B.
Okay.
Yeah. But like I said, I'm going to give you the points back. But from now on, remember, I know the calculator is giving you that, but the formula that we have taken in this course is a
Okay.
little bit different than other books.
Okay.
So there is always this discrepancy with percentiles.
Okay. And then also on number 12, if we got half of it right, is that half credit or do we need to get both parts to get full?
What was number 12?
Because like I had D, so I had the first part right, so I didn't know if that was like partial credit or not.
See, I think I already, how much I took off? 5? I think so we had a 15 problem, every problem is okay.
Oh, so you already gave.
I can probably give you one more point. Just talk to me next time.
All
Okay?
right. Thanks.
Yeah.
And by the way, any time she and my current grade.
Your current grade for this class?
Yeah.
Okay, where right here?
Yep. And
Is there any signature?
yeah. And the course name.
What's the
September 30th.
what should I write? Course title?
Yep.
Stat.
Start.
Statistics for engineers, I think.
Yep.
I think it's 2501. Credits 3.
Yeah, that's it.
Okay. Now I wanted to talk to you because I haven't posted the letter yet. I need to see you in my office before I do that. What time can you come today? Maybe can you come at 3 or do you have a class at 3?
Yeah.
You have a class at 3? How about 4 then? 4 o'clock you have a class?
Yeah.
Okay. Okay. Why don't you Do this then. Could you send me your? Do you have a CV or a resume? Because in order to write a letter, I need to know a little bit more so that about you, so that I can write more.
Yeah.
So
How about noon?
what's that?
How about noon?
At noon I have a class. All you need to do is maybe we can either meet then on Monday, but I don't know if it's gonna be too late though. Or you can send me a CV or something so that I can know more about you. Because it'll be better if I know a little bit more so that I can write a little bit more.
Okay, I'll send you the email.
Yeah.
And could you give me some detail? What do you want to know?
Yeah, I can send you an email with what are the things that I want to know. Yeah.
I'll try to stop by.
When is the due date again, you said?
The first one is the October 1st. But
October 1st. So I have this weekend then. Yeah. Okay, so I'll send you an email then, and
Thank you.
tell me as much as you can.